Okay, so today we're going to talk about equations of a line. I am sure you have all covered them before, so we're just going to look at all their basic properties really quickly and then move on to some problem solving. So first off, the first thing we care about when talking about the equation of a line is the slope. So if we have some line like this, you have all seen this before. The slope is, you can find it different ways. We generally call it M, and you can call it rise over run. You can call it delta y over delta x, which means change in y over change in x. If you want, you can call it change in y over change in x. Or if you prefer, we can actually use a formula, which I'm sure you've all seen before, y2 minus y1 over x2 minus x1. And that just tells us how the line changes. So for the sake of argument, if this is the point 0, 4, and this is the point 1, 6, we want to find the slope of the line, so plug it into the formula right here. Label this, call this the first point, so this is x1, y1. This is x2, y2. Now, according to the formula, the slope is y2 minus y1, so 6 minus 4 over x2 minus x1, 1 minus 0, which is 2 over 1, which is 2. So the slope of my line is 2, which means it goes up 2 and over 1. So if we wanted to graph it, if this is the point 1, 6, the next point would be 2 up, 1 over, and we'd get the point 2, 8 right here. And if we want, we can plot several points that way and then sketch our line. I'm aware you've all done slope before, so we're not going to spend too much time on this. Essentially, basic properties of a line as far as slope goes. Slope can be, for the purpose of this class, positive, negative, 0, or undefined. We read our lines left to right. If the line goes up, reading left to right, it's got a positive slope. If the line goes down, reading left to right, it's got a negative slope. If you have a 0 slope, that means you're not changing. It means you're horizontal like this. The last type of slope we'll see is undefined slope. Undefined slope occurs when you have a vertical line, like that. I'm not going to take the time to pick points and plug all these in. You can do that on your own. I'm sure you've done it all before. All we really care about is being able to identify our slope using the formula, and then from there determine if my line is going up, going down, horizontal, or vertical. Once we have the slope of a line, we care about different equations of a line. As far as it goes, there are 3 of them that we're going to look at. The first one that most people know is slope-intercept. And the equation is y equals mx plus b, where m is my slope and b is my y-intercept. So, for the sake of argument, if I have the equation y equals 3x plus 2, that means 3 is the slope and 2 is the y-intercept. And then from there we can graph it. We know the intercept is 2, which is the point 0, 2, right here. Slope is 3, which means I go up 3 and over 1. So I'll go up 3 and over 1. Let's see if that's 0, 2. If I go up 3, I go to 5 over 1. And I get 1, 5. If you want to plot more points, you can. But just from here, we can get a rough sketch of my line right there. And we're good. This is the equation of a line that's most common, so I'm assuming you've all used it before. So we're going to look at the other 2 a little bit more. The next one is called standard form. Standard form is ax plus by equals C, where A, B, and C are all integers, and we're going to make sure that our leading coefficient, our A, is also positive. So for the sake of argument, 2x plus 8y equals 6, or x minus y equals 4, anything like that, those are equations of lines in standard form. As far as it goes, though, when we talk about lines, we really care about graphing the line so we can see the slope and things like that. And the question becomes, if I have something like, we'll use this one, 2x plus 8y equals 6, what does the graph look like? Does it have a positive slope or a negative slope? What's the intercept? Things like that. And algebraically, how do we do that? And all we really have to do, solve for y. Put it in slope-intercept form, and then we'll be able to see what the graph looks like. So to do that, subtract the 2x over. We get 8y equals negative 2x plus 6. If you want to put the x term second, you can. It doesn't really matter, as long as you know that in slope-intercept form, the coefficient of x is your slope. The order doesn't matter. Now divide by 8. You get y equals negative 2/8x plus 6 over 8. Reduce your fractions. Negative 1/4 x plus 3/4. Now I have my slope and my intercept, and if I wanted to, I could graph it really quickly. The intercept is 3/4, so say it's right there. My slope is negative 1/4, which means I go down 1 and to the right 4. Make sure when doing this, you make your line go to the right so it goes down. It doesn't go left just because it's negative. So we go down 1, we're at 3/4, so down 1 would be negative 1/4, and then over 4. So right about here. And now I can draw the line between them and I'm good to go. For the purposes of this class, we're not going to spend a lot of time plotting 33 different points and making sure my line is absolutely perfect. We care about the rough idea of a line and how it works with the slope and an intercept, whether the slope is positive or negative, which tells me if it's increasing or decreasing. So we don't need to spend a lot of time plotting a lot of points and making sure that's perfect. The question then kind of becomes, well, suppose you have something in slope-intercept form. Like y equals 2x plus 5. Since we have different forms of our equation of a line, we want to be able to go back and forth between them. That's slope-intercept form. Put it in standard form. Algebraically, what does that mean? It means get the x and the y on one side and the constant on the other. So for this, subtract the 2x over. You get negative 2x plus y equals 5. All my coefficients are integers, but we have the other rule that the leading coefficient can't be negative, so multiply everything by negative 1, which really just switches the sign of everything. So we get 2x minus y equals negative 5. And now that equation is in standard form. The last type of equation we want to look at for right now is what's called point-slope form. Point-slope form is y minus y1 equals m times x minus x1. As far as it goes, when we name things, we're not too original. Slope-intercept form is called slope-intercept form because it gives you the slope and the intercept. Point-slope form is called point-slope form because it gives you a point, x1, y1, and it gives you the slope, m. And then you just plug them in. So for the sake of argument, if I had y minus 2 equals 3x plus 4, that's the equation of a line. What's the slope of that line? Well, it's the coefficient out in front, so 3. What's a point on that line? Here, make sure we do things in order. The x actually comes second for this one, so make sure to reverse it. And keep in mind, these negatives are part of the equation, so when you're finding out what the point is, flip the signs. So if this is x plus 4, the x value is negative 4. If this is minus 2, the y value is positive 2. That's a little confusing. Just switch the signs and you'll be good to go. But what that means now is if I wanted to, I could graph the line. Because I have a point, negative 4, 2. So we'll say negative 4, 2 is right here. And now my slope is 3, which means up 3 over 1. So from negative 4, 2, go up 3 and over 1. And we get negative 3, and if we go up 3, 2 plus 3 is 5. I have 2 points, draw the line between them, and I'm good to go. Ultimately, we'll be going back and forth between all 3 equations of a line. Generally speaking, people want their answers in slope-intercept form. Personally, I don't really care. As long as you can find an equation of a line, be it standard form, slope-intercept form, or point-slope form, it's completely fine with me. If you're used to putting in slope-intercept form, then just put all your answers in slope-intercept form and you'll be good. It all just boils down to doing a little bit more algebra. But for one last little problem, just to kind of tie all these together, suppose I have the equation y plus 2 equals 1/3 x minus 4. That's a line in point-slope form. The slope, if we care, is 1/3. The point, again, switch the signs, is positive 4, negative 2. So I could graph that if I wanted, but for now, put it in slope-intercept form. Or actually, we'll do that on the way, put it in standard form. So how do we put it in standard form? For standard form, we need the x and the y term on one side and the constant on the other. So first, get rid of the parentheses. So we'll get y plus 2 equals 1/3 x minus 4/3. Now in standard form, we need the x and the y on the one side and the constant on the other. So subtract the negative 1/3 x over. We get negative 1/3 x plus y equals, subtract the 2, minus 2 minus 4/3. If you want to combine these right off, you can. But ultimately, we have a problem because we said all of our coefficients have to be integers. 1/3 is an integer, so we have to get rid of it. So do the trick we used earlier to clear fractions. Multiply by the LCM. For the 2 fractions, the LCM is 3. So multiply and we get negative x plus 3y equals negative 6 minus 4. Which, of course, we can make negative x plus 3y equals negative 10. But we still have one more step to go because now we have all integers, but the leading coefficient is negative. We said leading coefficients can't be negative, so we do the same trick we did before, multiply everything by negative 1, which just switches the sign of everything, and we get x minus 3y equals positive 10. And there's our line in standard form. As an exercise to make sure you're actually doing the algebra right and applying all this correctly, graph this line right here in point-slope form. Then do all of the algebra, get it in standard form, and graph the line in standard form. They're the same line, which means the graphs have to be the same. If the graphs aren't the same, go back, check your graph, check your algebra, and see what you did wrong. In the next video, we're going to look at some applications of this and then go from there.